Hello and welcome to the On-Premise IT Roundtable, the only podcast that dares to be both on topic and on location. My name is Tom Hollingsworth and I am a part of the Gestalt IT community. And each episode we bring you the viewpoints of a group of IT luminaries on a specific topic, a premise, if you will. And we figure out if it holds water or not. I'd like to take a moment for our panelists today to introduce themselves so you'll know a little bit more about who they are before we jump into the premise, starting with Jordan.
Hi, Jordan Villarreal, System MTU1 on Twitter, YouTube. I'm a long time network engineer.
Awesome. Jason?
Jason Gintert, Bits in Flight on Twitter, and been a network engineer for 20 years.
And Martin.
Hi, I'm Martin Duggan. You can get me on Twitter at MartinCCIE7942, and I'm a network architect.
So, as evidenced by the fact that we have a panel of networking folks here, we're going to talk about some networking. So let's jump into today's premise. Networking is easy, right? All it is making the packets go from one side to the other. All I have to do is plug everything into the right port, make sure all the lights are green, turn on RIP, and it works just fine. Well, if that's the case, why is it so hard to get networking working? I mean, all it takes is a sunspot or a supply chain issue or, I don't know, a butterfly flapping its wings and suddenly nobody can get to Amazon. And have you figured out why everything is running so slow yet? Yeah, folks, it turns out that networking is a little bit harder than you might think. In fact, the premise of this episode is that networking is too complex. All right, so let's go all the way back to the late 70s, the early 80s. We're looking at the introduction of things like Ethernet. Bob Metcalf is doing amazing work at 3Com, and it's real easy. We want that thing to talk to this thing, and we want to make it work. And then we have like Radia Perlman, and they're like, well, we have this problem. We created this thing called a bridge, and you plug one thing into one end, and you plug one thing into the other. It sends the packets where it's supposed to go. And some idiot grabbed it, and the first thing they did was they plugged it into itself and crashed the whole network. So that was the very first, I would say, moment when we added complexity to the network to solve human interaction problems by creating spanning tree. And it generated a cool poem. But flash forward to today, where there's so much complexity in the network for a variety of reasons. It's a veritable alphabet soup of acronyms and terminology. And as I said to somebody the other day, I can have a conversation with any of you that's 85% acronyms and we can understand each other more clearly. The only people who have conversations like that are doctors. How did we get here? What happened?
Tried to make networking easier.
But how did we try to make it easier and then make it more complex?
By adding complexities on top of things that never got to go away.
Such as?
Well, let's say I'm trying to use OSPF to connect two routers together.
Okay.
And it's a couple lines of code. Mm-hmm. Well, what if I've got a router over here and my other router is ACI or any sort of data center orchestration system? I don't just have to know the routing anymore and the 5 commands to make it work. Now I have to have 5 commands over here and an entire fleet of engineers to deploy this just to get my data center to talk outside of my data center.
Okay, so I've been into that situation before. I can just configure a static route and then I'm done, right?
Well, sure, you can do that, but you're not inheriting an ACI. You're not inheriting one of these new data centers, these new design data centers. Typically today, you're putting that in. So now if I'm a network engineer and my data center, okay, my Nexus gear is obsolete, what am I going to replace it with? I'm going to go with the new ACI. If you stick with traditional network, Nexus networking, it's relatively straightforward, but we got to make the network do more. So now you have all of this administrative overhead that you have to stack on top of just trying to make that routing work.
So we've not only added complexity on top of things, we've added functionality requirements. It's not just that the network is a dumb transport anymore. The network has to give me value for what I'm doing, whether it's low latency connections or quality of service that prevents someone's YouTube video from eating up the bandwidth that I need to be able to do some kind of like, I don't know, phone call or something like that. So we've asked more of the network. How have we provided for the network to be able to deliver more while still making it something that is not horribly overcomplicated?
I think we've ended up adding lots of layers of abstraction, overlays upon overlays upon overlays, right? So you've got like EVP and VXLAN where underlays is like traditional layer 2, and then you have layer 3 on top of that, and then you're putting layer 2 back in, an encapsulation over top of layer 3. So you have all these layers that a network engineer has to understand, and a lot of traditional engineers that came up in a the standard layer 2, layer 3 environment, trying to troubleshoot and understand the complexity inside of something like that.
It's been pretty hard trying to keep up with that. If that was a layer 2 network with Ethernet, and then it's something like fabric path, and then the next 5 minutes later is it's OTV, and then it's VXLAN, like you said. It's just trying to keep on top of that is so hard.
But think about that specific example that you gave, Martin. So we talked about Radia and spanning tree. Spanning tree works, but it doesn't scale, and it has problems. So we need to come up with something better. So we have Trill. Except I don't like Trill because of this one thing. So I'm going to create Fabric Path, or I'm going to create SPB. I'm going to create a solution that is very similar and accomplishes the same goal, but I own it. And I don't have to give it to anybody else, but I can sell it to them. And now that doesn't even solve my problem. And now I have to do something like EVP and VXLAN, or I have to add like some kind of weird MPLS stuff in my data center core in order to get this. And now all of a sudden, I've built enough layers of abstraction on top of what I'm trying to accomplish that it's not even a network anymore. It's a stack of protocols that are riding on top of Ethernet, and God help me if any of them go down. Why would somebody do this?
I'd say, unfortunately, it's because we still have a requirement to stretch layer 2, and I think as a network engineer, everybody just hates it, but we have to kind of live with it.
Well, why? I mean, Netflix never goes down.
I think operationally, layer 2, there ends up being like just catastrophic issues that for example, I've seen a case where a large organization with a very large layer 2 environment, they kept going down from spanning tree issues and loops. So their solution was to put an overlay over the top. But then after they did that, they couldn't find any engineers that could actually support that. But it stopped the issue of having outages from loops and spanning tree issues, but then finding people to run it operationally.
It introduced a new problem of complexity by trying to remove the old problem of being too complex.
And I don't think you ever really truly remove the old problem. Because you can stack, and this plays out a little bit in the cloud, you can add as many overlays as you want, but go back to OSI, go back to the 7, you can stack whatever you want, but if you drive deep enough, you're going to expose the same problems that you were trying to solve, and they still exist. And now you've got an overlay sitting on top of your underlay, which is still susceptible to problems. So now I've got to know my overlay, and cool, I can do fun, fancy things with it, but if my underlay breaks, I still have the same fundamental problem, and now my overlay is broken as well.
So let's just rewind again back to this thing where we talked about the fact that the network needs to have more performance, it needs to be more reliable, it needs to solve problems. What kind of problems is my transport supposed to solve? And I'll tip you off a little bit kind of where I'm taking this. vMotion, OTV, stretched layer 2 clusters across coasts. Why do I need vMotion? In theory, now that we've had 20 years of visibility into this, that was the dumbest idea you could have imagined. I'm going to make sure that when the thing moves from Los Angeles to New York, it keeps the same IP address and MAC address. Why? So obviously the application is a tenant of my network the same way that UPS is a tenant of the interstate system, right?
Right, but I mean, your roads have to work if UPS is going to get the package to your house.
But if UPS has a problem with how many packages that they can ship down the road, is it my job to build better roads so that they can use different trucks on the roads? Or is it UPS's problem to fix their trucks? Or planes, or whatever they're using to utilize my transport system?
I think we all inherit requirements and we have to work around those. But if we were going in fresh in greenfield, nobody's going to recommend stretch layer 2. We always start this way. Layer 3 is where we start.
And we have years of experience that comes back now and tells us that, and the Netflix never goes down joke is pertinent because Netflix doesn't stretch layer 2 across, Reston and Corvallis and wherever else they are. they have an application that is tolerant. So we've heard things like site reliability engineering. We've heard things about people who have a grander vision of things. But part of what it comes back to, whether you want to call it DevOps or whatever else, is that the tenants, the customers of our network, we now have visibility to go back to them and say, I'm not fixing your stupidity with HSRP anymore. Write your application so that if a gateway goes down, it looks for a new one. Is that one of the reasons why so much complexity has been introduced into the network? Is because we were trying to solve problems that technically weren't ours to solve in the first place because we couldn't get anybody else to solve them.
Yeah, I think that's definitely true, that network engineers haven't pushed back maybe hard enough on the applications teams to say, look, I'm not doing that. Instead, we've just kind of gone along with it, tried to make it work. I had this good conversation with somebody about EVP and VXLAN, and I asked, is it good enough now that you can tell people like stretch layer 2 is okay? And he said, absolutely not. You should still push back every single time and say you shouldn't be doing that. And only if there's no other option, then you use EVP and VXLAN or something like that to extend it. But you should try to push back, and you should try to make sure the applications are designed appropriately, and you shouldn't be stretching layer 2.
Pushback is hard though when you have the business requirements. They're saying, no, my application is here. I have a built application that we've been using for 20 years. It's difficult to find coders. The original coders are all gone. And now you're telling me that I have to invest all of this money to make my application new again? Or you just adapt your network because we know you can do it?
Right, because it's a whole lot easier when you have a sunk cost engineer sitting around fighting fires on a weekly basis when that application misbehaves and I need to keep tweaking the network to keep it up and running, because that is an amortized cost over time of operations and not a development cost that gets passed along in my cost center. Fix my problem for me because I don't want to pay to fix it. And yeah, it sounds like I'm a little bit cynical, but HSRP drives me nuts. So we've added complexity to the network. We've made this thing essentially a self-fulfilling prophecy. It's not reliable because it eventually will crash. But not all networks are like this. Some networks are very simple. I mean, go to any AWS control panel in a VPC and tell me all of the really cool things that you can enable, like carrier-grade NAT, VXLAN. Oh wait, they're not there. It's a network. You put an IP address on it, you define a gateway, and it works. And it works well. So how is it that we, as enterprise engineers, have built this unwieldy beast of a thing that we cannot tame or control, and Jeff Bezos and Andy Jassy said, we'll make it so simple it can't fail? Where's the disconnect?
I think we gave people too many options. Amazon said, this is what you get.
It's the Henry Ford model. You can buy any car you want as long as it's black.
Right, exactly. You get the options we give you, and that's all there are. And I think we, try to appease those application holders and make things work, because the technologies do exist to do so. But maybe we shouldn't. Maybe we should be pushing back more as network practitioners.
I think as a designer, I very rarely get a clean sheet. So it's generally brownfield. You've got to come in and fix something, add something, make it scale, divest, etc. So I will try and keep something as simple as possible. It's not me that has to support it, but I know these people and I want to carry on working with them. So I will keep it as simple as possible.
So when we went to cloud, and you just mentioned brownfield, everything that Amazon put together didn't really exist prior. So all of the networking, traditional networking that we've had forever and ever built up to a point, and when cloud came out, it essentially became greenfield. So you didn't have those options. Anything that you were going to develop net new had to conform to the boundaries that they put in place. You want on this playground, these are the rules. You can't break out. You have to adhere to it.
And that's one of the things that really drove it was, look at the number of companies that are trying to lift and shift their applications to the cloud, and they're breaking horribly. It's because those applications do not play well in an environment where their safety nets no longer exist. I can remember working in a VAR where someone was trying to run an old, really old green screen application, like an AS400 terminal application, over a private T1, and they wondered why it was so slow. I'm like, you realize this application was designed to work with like less than 100 milliseconds of latency, and you're trying to run it across a state. But it's always worked before. Fix it. And I think I want to come back to Martin's point about this, because this is one of those things that we kind of get into when we get away from the technology. We get into the political side of things in the network. I have to work with these people. I want to continue to work with these people, and I want to make things as low friction as possible. But what if that developer doesn't feel the same way? It's not my problem. Fix my application however you can. If that means you've got to buy a faster hard drive, if that means that you need to put a 100 gig switch in here to make it work because I have no concept of things like buffers, just do it, because I'm not going to invest any more of my time fixing this thing. And eventually we just kind of go, fine, whatever. How do we convince the rest of the stack, the development side of the house, the management side of the house, that we are fixing problems in a place they shouldn't be fixed? We are patching things instead of actually fixing them.
I think things like reference design and good practice, and just sitting down with these people and explaining why, so they fully understand it. I think they've done it since from whenever, and they're used to doing it. We need to probably educate them a little bit better. But there's also another element where some guys, in our industry, they're very creative and they love a challenge, and they would jump and say, I can make that work for you.
If it was that easy, I feel like it would have been done already.
Let's address that point, because we've been working from the Jedi Knight side of the fence, that we're altruistic and we're trying to do our best to do what's best for everybody. But allow me to become a Sith Lord for just a moment. I'm making my network more complex because only I can understand it. And as long as it's complex, I'm the only one that can work on it. And you can never fire me, because who's going to fix it?
Well, of course, you've documented it, haven't you, Tom? So somebody else can check out your design. And
you know what? It's over here, but you don't need to read my documentation. Just ask me. I'll fix it for you. It is the Brent problem from the Phoenix Project, right? There is one person in the organization who everything depends on. Now, obviously, if Brent ever gets hit by a bus, we're in trouble. But I'm not saying I know those people. I'm just saying that there are enough stories of people who have made things more complex than they need to be, specifically for the purpose of keeping their job, that it's not rare to find them. How do we deal with that?
Fire them, and you eat the cost as a business lesson.
So what ultimately is the cost if I have to go back and I have to unwind all of the crap that you forgot to document, and you spend hours in a terminal window going, how does this work? Like how do you explain that to your business owner, your CIO? Yeah, so it's going to cost us $10,000 to fix this problem, but we can do it for $5 if you're willing to be down for a weekend.
You let them know that at least it was under your control and they didn't get hit by a bus.
Yeah, that's fair.
Yeah,
Nobody wants to get hit by a bus.
Because if you're genuinely to that point, what you're playing with there is a time bomb. Mm-hmm. It's going to go off one way or another. And if you have recognized that, if your management has recognized we have this problem here, it's not a matter of if, it's a matter of when. So if you can control it and you sell it in that way, I think there's a path forward of, well, now it's at least under our control. We can prep for it. You can't plan for the unknown number of unknowns that will ultimately come out of that. But if you can find it, I think you can sell it that way.
Yeah, we would generally raise a risk, and then at the exec level, it's risk acceptance, and what do they want to do about that? Are they comfortable with that risk? And if not, let's make a plan so we can get out of it.
Identifying the issue and being open and honest about it, with management, and giving them options. This is where we're at. This is the best way out.
Obviously, we hope we don't have any Sith Lords out there in our network, but it occurs. So aside from maybe entropy, I'd say complexity is the one other thing that seems to always increase in our networks. But unlike entropy, complexity is not a fundamental force of nature, and we can stop that. So as network engineers and architects and people who have done this for years, how can we head off the increasing complexity in our networks? What's something that people can do today to reduce that amount of complexity?
I think that if you can truly adopt the new and let the past be the past, that's a good start. So you don't have to keep dragging along legacy protocols, legacy designs. Because back to the original example at the top, if I have, I'll just say generation 1, 2, and 3, but I have to maintain 1, 2, and 3, I can have all this new whiz-bang stuff over here, but if I can't let the past go, like old RF scanners that still need to use the low 2.4 rates, if you can't get rid of that, it's going to drag everything down around you. You've got to break out of the past to have a chance to let the future breathe.
Russ White says pretty eloquently, separate complexity from complexity. And I think if we've got an area like that in one customer network, we kind of push it to the side and keep it there and just hope that it doesn't affect the rest of the network. So we put tools in place to make sure that doesn't happen.
Contain the complexity.
Yeah, and just focus on simple designs. Try to, push back on other folks where needed to keep it as simple as possible to achieve the objectives at hand.
And it's education as well. If there's some complexity out there, it's kind of educating the people that got to look after it. But I've seen, there can be some reluctance to go into something too new and too deep. So yeah, keep it simple.
So obviously complexity is something that's never going to go away, whether it's a network or a system or cloud or whatever. We're always going to have more complexity. Key is how to identify where it's happening and how to prevent it from spreading. And it's not always easy, but you have to have a good plan in place. You have to have good people willing to execute on it, and you have to understand what the end goal is. And as we've mentioned, sometimes it means you have to push back against people. Sometimes it means you have to figure out how to adapt what you're doing to what you have and not the other way around. We're not always going to have the opportunity for a massive paradigm shift like we have in the past few years with the cloud to basically say, you do it this way or no way at all. But as our panelists have said, if you go into it with open eyes and structure, you can limit the amount of complexity that you introduce. And if you start small, you'll end small. But if you start with no guidelines, well, it's a pretty complex problem to solve. That'll just about do it for this episode of the On-Premise IT Roundtable. I want to thank everyone for tuning in, and I want to thank our panelists for being a part of it. Remember, if you want to catch the latest episode of this podcast, you can go to gestaltit.com/podcast. You can also subscribe to us in your favorite podcast application of choice, whether that's Apple Podcasts or any one of the number of apps that are out there. You can also see us in iTunes. And if you do, would you do us a favor and leave a rating and a review so that everybody kind of knows what we're all about here, that this is an enterprise tech podcast that's short, sweet, and to the premise. And that way people can read that and understand what we're doing. We'll be back with another episode in a couple of weeks. We hope that you'll tune in for that. And remember, if you have any premises that you would like us to debate here, we're on Twitter as @OnPremiseIT. You can absolutely send one over that way, and we'll check it out. For myself, Tom Hollingsworth, for our wonderful guests, and for our Gestalt IT community, thank you very much for tuning in. We'll see you soon.